Hello everyone. Today we discuss CP, that is complex engineering problem. So our complex engineering problem is to design an aircraft pitch control. We have to do system modeling, analysis and control for this. So the basic idea is that we have to control this angle theta that maintain the pitch. Now this is the physical setup. It is all we already developed some mathematical equations. Now if we move further, we also have available with us the transfer function p of s in state space form and also in transfer function. So the problem statement that we have to target is to design a feedback controller to satisfy the following design specification. First one is overshoot less than 8%, rise time less than 2 seconds, sorry, settling time less than 8 seconds, and steady state error is 2%. So first of all we have to open the Matlab and just do a coding for this transfer function. So just I open my Matlab here. Okay, so this is complex engineering problem, clear or close or then CLC. Then I use the command S operator. Then I put the P of S, the transfer function of the pitch control, that is 1.15 S. So this is the pitch point. Now the specification, that is rise time is 2 seconds, overshoot is 8%. From here I calculate zeta and omega n. Now what I do here, I just run that bit. Okay, alright, and this R locus. So when I do that, when I evaluate it, so this is the root locus. So the main idea is to look here, or we can able to design with gain controller. So this is first thing that is clear if I introduce the specification. So I just close this one and go to my notebook here. Okay, so this is the transfer function. Look here, we have a pole here, we have a 0 here. So this is the requirement of steady state. This is overshoot. These are my root locus. So if you look at, this is the rise time. Okay, if you look at clearly here, so we have to find something here. Okay, so that we can satisfy that transient response. So now the issue is that we have to move this root locus to this direction. So I select a point here and I say, for example, this point is -4 plus j, where I want my closed loop poles. So this is the point, because we have to improve the transient response. So obvious design is PD design controller, because we have to improve the transient response. So let's see how we do it in Matlab quickly. So if I open the Matlab, I use CISO tool and put P here. Now when I do that, I come up with this window. Alright, so if I just go unedit, okay, if I go to okay, so this is the requirement, that this is the rise time, this is overshoot. So look here, we have root locus here. I can do anything. I can't achieve the desired specification. So how I include these things is just using this new and design specification, and I put the values here. Okay, so this will give me this thing. Now the issue is that we have to design control that satisfy, because gain control can't do it. Now let's see how gain control will perform. So here this is the gain controller. What I did, I also include here the design specifications. Just right click and if we have designs, I just include on the what you say, step response. So look here, this is white area is allowable area, where I have to put my response, but here response is not within the allowed ranges. So this means that the gain control is not satisfying. So let me check for you. For example, it is very clear from the root locus, but if you want to increase the gain, so you are unable to manage it, so especially for settling time. All right, so what we have to do, so this means that we have to design some PD controller so that we can improve the transient. So what I do, I just go edit design, and here this is the value. Okay, so what I did, I just right click here and add 0, because PD is with the 0. Now location I choose was something, let's say I'm not calculating here, you have to calculate yourself. I just put -2 here to show you how this will, so it's not working in my case, so I have to change the location to -4, for example. Now it's look better. All right, so look here, it's look much better. So what I did, I just push this again away from my specifications, and look here, everything is settled. So I achieved, I am within the white range here, and design is done. But the thing is, what you have to do, you have to design stepwise. Okay, perform all the steps. So look here, this is my controller design, this is the gain, and this is the location of my 0, okay, where I put nearly 4. Okay, now this is the way you can design your CP, and it's very easy. So it will help you on CISO tool to do it, but you have to perform all the calculations on paper, why you are designing this or why you are getting this much results. Look here, you can improve it by improving the gain. So this is the whole about CPs. Just do it and complete your report, also prepare your presentation. Thank you. That's all for CP.